Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series today, we're going to see about the bus structure in computer architecture. So before entering into this thing, first we have to see the bus. So bus can be used to connect the internal components of the computer, and also it acted as a shared medium between the entire component present inside the processor. So it will have a multiple components and devices are attached to the computer. So everything can communicate each other only by using the single bus. And also by using this thing, we can able to transmit the information signal to each other. So in this particular purpose only, we are using a bus. A bus can have the three different types of a line. One is a data line, address line, and control line. Everything's are connected together by using a bus. So only we can call this is a shared medium. What do you mean by data bus? First, we can say data. Data is for doing anything, we need the data. So, or we can call it as an information. So, data line coordinate in transferring the data among the system components. Collectively, we can call it as a database. Your database can have a 32 lines, 64 lines, 128 lines. Here, how we can calculate the width of the data bus means number of lines present inside the bus only defines the width of the data bus. And also here we are having it either 32-bit line or 64 line or 128 line. Each line can capable of transmitting only one bit at a time. We can able to transmit only one bit at a time. So the number of data lines in a data bus determines how many bits can be transferred at a data time. So this is the how we can able to calculate the performance of the system. It is also depend upon the width of the data bus. The next thing is the address bus. Address bus determine the source and destination of the data present on the data bus. Together, we can call it as a address bus because address and data bus are working together. Then only we can able to transmit information from one component to the another component. Here, the number of address lines in the address bus determine the width of the address bus. So the width of the address bus also determines the memory capacity. So your memory capacity can be determined only based on the how many lines present inside your address bus. The content of address line are used as a addressing IO ports. So here higher order bits determine the bus module and the lower order determines the address of the memory location or any other IO ports. The next thing is the control lines. The control line is the central part. It connected to all the components present inside the processor. It only passes the signal what to do. So to control and use of access of the data and the address line, definitely we need the control line. So your control signal consists of two type of a signal. One is a command signal or timing information. So your control lines are either, it can be a memory write. Memory write is this command cause the data on the data bus to be placed over the address memory location. Second thing is a memory read. This is the data on the address memory location to please placed on the data bus. IO write. This is also can be used for addressing IO ports and IO read. And also we are having a transfer acknowledgement. This line, control line indicate the data has been received from the data bus or it can be placed on the data bus. The next thing is a bus request and bus grant. Once for avoiding the interrupt between the component, we have used the bus request and the bus grant. First request the control over the bus. Once if it is a grantor, there is no interrupt can be interrupted component can be present inside the bus. The next thing is a request. Request indicates the interrupts or any bending. Interrupt acknowledgement is one, if you are receiving, it will send the acknowledgement signal to whom I'm going to service with the clock. The clock signal is due to synchronizing the operation. And also we are having a reset. If you want to reset anything, you can use the reset command. So your timing, initially I said that there is a two types of timing. One is a synchronous, another one is a asynchronous. Synchronous can be worked with the fixed clock rate and asynchronous can be worked on the variable clock rate. That is not depend on the fixed clock rate. So your synchronous bus indicates a clock in a control line. Fixed protocol can be used for communication, very little logic, and it can run very faster. Drawback is each device on a bus must run on the same clock rate. avoid clock skew. They cannot have a longer if they are fast. Asynchronous, if it is not clocked, it can accommodate a wide range of devices and also lengthen without worrying about the clock skew. It requires the handshaking protocol. Handshaking protocol is nothing but we have to receive the acknowledgement whether it can be received or not. That is must needed. Nowadays, we are using the asynchronous bus. So it can be defined in the timing manner like this only. So the lower part is the ideal stage. If we go move upper is the working part, data processing part, transmitting signal part, we can say. So this only we can call it as a one clock period. So this is the simple example for the sequence thing. This is a block diagram. This is a timing diagram. This is a sequence diagram. So this is the how it can be representation. So that's all about the bus concept. In next my concept, we're going to see about the technology and performance. Thank you for watching my video.